Here's what you missed in lesson 4.2.1. We're talking about burning stuff, so I'm very sorry that you missed this lesson, but we can catch you up on the material. So first we talked about how a combustion means fire and what exactly do you need in order to keep a fire going. And we talked about how in order to keep a fire going, you need oxygen, you need the fuel, and you also need a spark of some sort. And we talked about a couple different reasons too about why water puts out a fire. First of all, water is really good at absorbing energy. And so if you dump water on a flame, it absorbs all of that heat energy, and now you don't have that spark anymore. So that creates an issue. Also, water floods the area, and so the fuel can't access that oxygen anymore because it's surrounded by the water molecules. And so that creates an issue as well. So people had different ideas about that. We talked about how fire extinguishers have carbon dioxide gas, and that this is used because it's not reactive, it's not a fuel, and it's not oxygen. And even though it kind of looks like it, it's different. And so it also floods the area and prevents that fuel from having access to the oxygen. Then we did some demonstrations. We lit a hydrogen balloon on fire, which was pretty flammable. We lit a paper on fire. Wet paper did not burn, again because water is so good at absorbing that energy. We dipped a paper in alcohol, and that burned much more vigorously than the paper alone. And what we saw was the alcohol burned off first and then the paper. And then the carbon dioxide balloon did not, again because carbon dioxide is not a fuel. And then I did a cool one where I put a dollar bill in a 50-50 mix of water and alcohol. And it basically, the dollar bill is in flames. You think it's going to burn, but then it just goes out. So it does not burn. Kind of does. The alcohol burns, but the water protects the dollar bill from burning up. So in order to test each of these substances, again, we needed that initial spark or that initial flame. And that's to break the bonds of the fuel to start the reaction. The three fuels that were used in the demonstration were the alcohol, the hydrogen, and the paper. Why do you think some items did not burn? Again, they were not fuels. Then we looked at some trends. We had some different types of bonds, and we looked at patterns of will they combust. So something that we noticed about things that do combust is there are a lot of carbons and hydrogens, and carbons and oxygens are involved in those molecules sometimes, but not, or I should say carbons and hydrogens and oxygens, because carbon dioxide is carbons and oxygens, but that does not burn. And H2O, hydrogens and oxygens, just those two, also does not burn. And then we also saw that things with metallic bonding also burn. So this one was metallic bonding. This one was molecular covalent. I forgot we had to fill some of these in. Hydrogen bonding is molecular covalent, ditto. This one is molecular covalent. All non-metals and liquids and gases. Ionic is metal and non-metal, and molecular covalent for ethanol. So again, some patterns. Many things that have molecular covalent bonding do combust, but there are some that do not. Here are the ones that do. And then things with metallic bonding also combust. So things that did not combust were ionic substances, so the metal and the non-metal. And then, like I talked about, molecular covalent substances that have just carbons and oxygens or just hydrogens and oxygens did not. And also noble gases do not combust, like helium. Would we expect octane, all carbons and hydrogens, to combust? Yes. It's got molecular covalent bonding, and it's just carbons and hydrogens. That just looks like a fuel, just like some of the other examples on the table. It's very similar to hexane. Would we expect calcium chloride to combust? This is a metal and a non-metal, so an ionic compound, so no, we would not. Do we expect most metals to combust? Yes, many do. They all don't, but that's what the patterns are showing. So in order for something to be a fuel, it must be combustible. Then we identified which of these reactions would be considered a combustion reaction. Anything that involves oxygen as well as a fuel. So here's a metal and oxygen, and the other ones are all carbons and hydrogens in some form or another with oxygen. Finally, we looked at how electricity is generated in the United States, and a lot of our electricity is coming from coal, natural gas are the top two, and those are definitely involved in combustion. Petroleum as well. And the other ones, hydroelectric, nuclear, and then it just says other renewables, a smaller part of the pie, are not involved in combustion. And that was it for lesson 4.2.1.